So this workshop covers adding and subtracting rational expressions. So remember, if you're adding two fractions, they need to have a common denominator, and then you only add the numerators. So this example, 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3. Here we have an example where the denominators are already the same. This is like adding a fourth plus 2/4. It's 3/4. You just add the numerators. So here we also just add the numerators. 3x minus 4 plus 2x plus 5, all divided by x plus 3. And then we just combine like terms in the numerator. So I have 3x plus 2x gives me 5x, and negative 4 plus 5 gives me positive 1. 5x plus 1 over x plus 3. Fairly straightforward when the denominators are the same. Now, also note, this expression would be undefined when x is negative 3, because if x were negative 3, we would have a 0 denominator. If we are subtracting, again, if the denominators are the same, it's fairly straightforward. 2x minus 1 over x squared plus 2 minus 4x plus 4 over x squared plus 2. Denominators are the same, so again, we just have to subtract the numerators. But what you need to pay attention to here is you're subtracting this entire numerator. So, this is 2x minus 1 minus the entire quantity 4x plus 4 all over x squared plus 2. And again, this just means we have a negative 1, right? So we're distributing this. So we get 2x minus 1 minus 4x minus 4 all over x squared plus 2. And this will simplify to 2x minus 4x gives me negative 2x. And negative 1 minus 4 gives me minus 5. All over x squared plus 2. This expression is actually never undefined because x squared plus 2 cannot equal 0. If you think about that, x squared is always positive, and then we're adding to it. So this would be defined for all real numbers. But Mr. Trenfield, what if the denominators aren't the same? That's a great question. Because I know you were asking it, right? So, say we have x minus 1 over x squared plus 3x plus 2 plus x over x plus 1. Okay, so this is like if you're adding a half plus a fourth, right? In case you forgot, half plus a fourth. What you do in this scenario is you find a common denominator. We know that if we multiply 2 by 2, it turns into 4. But if we change the numerator, we also change the denominator. So we multiply by 2 over 2. This gives us 2 over 4 plus 1 over 4. Now, as I would like to say, we've reduced the problem to one we know how to solve. We add the numerators and we're done. Right? Same idea here, but we have polynomials. We're still going to find common factors, though. Which, of course, means we're going to factor. This denominator we can factor into x squared plus 3x plus 2 is going to factor to x plus 1 times x plus 2. Now we see what they have in common is they both have an x plus 1 in the denominator. This one needs to have an x plus 2 in the denominator and so that they can have the same denominator. So what we do is we multiply this fraction by x plus 2 over x plus 2. Now they have the same denominator. And of course, x plus 2 over x plus 2 is a fancy way to write the number 1, right? So now we have the same denominator. So we can go ahead and combine the numerators. And remember, this is x times x plus 2. So before we combine the like terms, we're going to distribute. So x minus 1 plus x times x is x squared. X times 2 is plus 2x. All over x plus 1 times x plus 2. Combine like terms, and we get 1x squared, 2x, and 1x make 3x, and minus 1. And this expression would be undefined at x cannot equal -1 or x cannot equal -2. This is where it's undefined, right? Can't divide by 0. All right, we'll do one last example with subtraction. Say we have 2x squared minus 16 over x squared minus 4 minus x plus 4 over x minus 2. Again, the first thing we need to do, factor. Because you can do this without factoring the denominator and just multiplying. You end up multiplying by more than you need. It's like if you're adding a half, a fourth, and a fourth plus a sixth, right? Quick way to do it is just multiply this by 6 over 6 and this one by 4 over 4. But that's not the most efficient way. In fact, all you really have to do is multiply by 3 over 3 and 2 over 2 to get a common denominator of 12. So this is what factoring allows us to do. X squared minus 4 factors conveniently into x plus 2 and x minus 2. Difference of squares. Now we can see we have a common factor of x minus 2 in both denominators, but this one is missing the x plus 2 factor. So we just multiply by x plus 2 over x plus 2. And now this gives us two fractions with the same denominator. So we have 2x squared minus 16 minus, now, don't get freaked out here. I just use the brackets because I have more parentheses. Because the first thing we have to do here is multiply this out, then we'll distribute the negative. Right? So, this gives us 2x squared minus 16. Now, I'm going to work this out up top. So, x plus 4 times x plus 2 gives me 2x, x plus 4 is 4x, and x plus x is x squared plus 6x plus 8. So minus x squared plus 6x plus 8 all over x minus 2 times x plus 2. And then we distribute the negative. So we get 2x squared, wow, this marker works better. 2x squared minus 16 minus, and the negative gets distributed to all three terms. So minus x squared minus 6x minus 8 all over x minus 2 times x plus 2. Then we combine like terms, and we'll get I'm going up here. And we get, there's 1x squared minus 16 minus x squared minus 6x, and negative 16 minus 8 will be minus 24. All over x minus 2 times x plus 2. Now, if we want to truly simplify this, we're going to check, can we factor this numerator? And in fact, what multiplies to negative 24 and adds to negative 6? Did we get it yet? Did we get it yet? I didn't get it yet. Maybe it's not factorable. So, there's our answer. And we have x cannot equal 2, x cannot equal negative 2. All right.